Now let's look at cross-site scripting. Cross-site scripting is also known as XSS, and it comes in different flavors. But let's talk about what it is first before we jump into that. XSS usually allows the attacker to execute any arbitrary client-side code on a victim's browser. XSS could be used in a number of ways, including phishing, exploiting data, account takeovers, and more. Think of XSS as a way where you can actually execute JavaScript onto a browser and control the behavior, especially within that website. So if a website like a bank is vulnerable to an XSS, we can start transferring money from one user to another, change their password, and so on. So how does that work? Let's say an attacker has a vulnerability on a website within the user's first name in the comment section, anywhere that they could insert any text. They insert their payload. The user or the victim that we're going after visits that page or clicks on the link, and as soon as they visit that page, it executes on the browser, and that payload is predefined to perform some malicious action. This action again could be transferring money from account to account, it could be changing their password, and so on. In a lot of cases, if our victim is an admin user or a user with special privileges, it could become even more dangerous. So for example, as an admin, if you have access to file uploads and other functionalities within the website, an XSS against that user could be very, very beneficial. The impact for XSS, it actually depends on a lot of different factors. This could be if it requires any user privileges, if we're accessing or if we're attacking any users with special access, depending on the data the site stores, and so on. But typically, a reflected XSS could be anywhere from medium, and a stored XSS could go up to a high or critical, depending on the end results. So again, I've mentioned the different types of XSS. The two very, very common ones are reflected and stored XSS, and also there is DOM XSS, which we'll discuss in a little bit. The first one being reflected XSS, the payload is usually injected from the victim's request. Usually you have to click on a link because it is in the address bar of the website. So it could be something like example.com/something equals to our payload. Versus the stored XSS, it's actually stored server side. So anytime a user visits a particular page, it pulls that payload from the web server or from the database and it shows it on the screen. DOM XSS usually is some sort of a client-side code versus the server side. The injection typically still happens on the victim's request, but it gets passed through a different function or different JavaScript code for it to work. So let's look at reflected XSS. In the example on the screen, you can see that we're going to site.com, some random web page, and there's a parameter called name that takes your username, whatever you put in the search box or whatever you put in the website, it gets put into that address bar for name, and the response would be hello John. So that message John could be anything, and whatever we put in there, it gets reflected back onto the page. And that's a normal request. That's what it's supposed to be functioning as, and it returns whatever we give it. Now imagine if we put some HTML code in there. If we put, for example, the HTML code for underline, which is the U tag, if the application is not vulnerable to XSS, then it's going to come back and say hello HTML tag John closing tag, which kind of yields that there is no XSS. However, if this was actually vulnerable, when the application returns a user input with John and the underlying tags around it, it would actually underline the text that we have given it. Just because we have HTML injection doesn't mean that we have XSS, but in a lot of cases there is a way to escalate to XSS. So the best way to actually look for XSS, in my opinion, is to actually look for places where you can insert HTML, and if the website comes back and renders that HTML code, then there's a possibility to look for further XSS vulnerabilities. Some of the examples that have been found previously on Facebook, for example, is, as you can see, the Q parameter in here on facebook.com translation has been swapped out from a text to a payload where it says, hey, I want you to use a script tag, and I want you to pop up with an alert, and within that alert, I want you to do document.cookies. And as you can see right here, it's returning the user's cookie, and it's telling us that there's an XSS. If you're not familiar with script tags or JavaScript, I highly recommend looking up some resources, and I'm also going to make sure to attach it to this chapter of this course. Stored XSS, on the other hand, is also known as persistent XSS. Again, this XSS payload usually gets stored somewhere in the database, and then later on it would be shown to any user or particular users once that information is looked for. So for example, if you leave a comment on a website, the website's going to be stored in the database, and anytime someone loads that page where your comment was made, it will bring it up and show it. We can use that for XSS, especially if it allows us to inject HTML with JavaScript within it. As you can see, there was a very famous stored XSS recently that happened in 2014 on TweetDeck. So any user that would see this tweet, it would retweet this, so their followers would also get this, so their followers would retweet it, and so on. So everybody that would see this script tag or this XSS payload would be vulnerable to it. And again, this was stored on to Twitter, and there wasn't any user interaction required. On visiting this, because of a retweet, again, it would trigger it over and over and over again. There's also other examples of it right here. There is on Facebook, it's an integration from Dropbox, where a file name was set to an XSS payload, and as soon as you go to Dropbox and you select your file, the XSS payload would pop up. We'll look for those in a little bit on the hands-on lab, but always think about anywhere that you can put any user input or any text that you can input to the website could be a potential for XSS. And last but not least, there is DOM XSS. This is typically when JavaScript reflects data from an attacker-controlled resource. For example, this could be within the URL, and then it passes on that data to a function later on. Consider the following piece of code. It's actually an example from a HackerOne report where it's looking for a location, as you can see right here, to load a particular page within that visited website. All we have to do is swap it out for some HTML code and JavaScript, and then it would be able to pop an alert or whatever we're looking for. Consider this piece of code. As you can see, it's looking for some location. Again, if you're not familiar with what these are, I highly recommend familiarizing yourself with JavaScript. But in this case, the page is going to rely on whatever comes after this pound sign to load the next resource. So this could be a contact form that it loads by clicking on a link within that same exact page. So if you understand how this works within JavaScript, you can replace that page with some of your own HTML code with JavaScript within it and get an XSS to work. Again, DOM XSS is one of those things where you want to learn about JavaScript before you start looking for it, because it relies on you understanding how the code works and where to look for it.